Good morning, everyone, and thanks Cindy, inviting me to talk about computer science. And I'm going to talk about computer science. In addition, I also talk about my research in Internet of Things and smart homes. And my name is Guai Xu, and I'm a professor at the Arizona State University. I got my PhD from University of Minnesota in 2006. So I've been at ASU since 2008. So I'm going to talk about what is computer science. So you guys might hear about AP in computer science in the high school, right? So basically advanced placement in computer science. And essentially computer science is a study of computers and computational system. For example, you heard about AI and artificial intelligence, for example, self-driving vehicles, we have been seeing them on the road. And computer system, and you might see the Raspberry Pi, and I have one small, just like this is a computer, just can't imagine, it's very tiny, tiny piece of equipment. Essentially has CPU memory. It's generally, you can consider as a small computers. Cybersecurity, and right now we're living, and in a lot of challenges, security and safety, and we have been using two-factor authentication, right? Sometimes you log in the website, you're not just username, password, you also need your phone, right? They send you a message to prove you are really you, you hold that phone number when you register. And another aspect, computer science is database system. One example, excellent example is the Walmart data warehouse. Walmart probably one of the largest data warehouse in the world because they have a lot of inventory, custom data, product data, price data, and sales data, etc. Another aspect, computer science, computer graphics. We see animation movies, right? There's a lot of techniques using computer graphics. And for the Star Wars, they are not real, right? That's basically, many images and, and scenes are rendered, use computer graphic techniques. Computer networking. So I'm highlighting here because, I'm a research in computer networking, and I got my PhD in computer networking. So I'm going to talk about a little bit on my research on the internet, but I'm not going to, spend too much time because it takes probably, in a couple of hours to talk about, research papers. So I'm just give you a little bit and taste on that topic. What is the internet? Many of like today, which is, what internet is TikTok, right? And is Instagram, right? It's a Facebook, it's YouTube, and it's Google, and it's Pinterest. Maybe 10, 20 years ago, people, it's internet, it's Yahoo and AOL, right? If you ask your parents and grandparents, so they might say, hey, internet basically just Yahoo and AOL. And this is from the service perspective. But if you ask research, like people like me, I'm going to say, internet, not just those services. And internet is the infrastructure. So basically there's under the hood, there's a lot of work, have been done, by internet pioneers to support those services. Right? So here, this is one example. And this is, a graph I taken from CADA, one research organization. And if you see, this is, probably just too big. So I can, I see a very clear picture, but you can see the dots. Essentially just the nodes on the internet, how they connected. So essentially, internet has to connect, otherwise just like phone call, right? And the cell phone company connect us. So the internet is essentially ISPs, right? And your school, your coffee shop, they're all connected. Right? And some nodes are more connected than others. So you can see, the size of the dots, right? And essentially, this is the infrastructure which is power the services on the internet. Then you might, what is internet of thing? We hear it a lot. Essentially, just internet connected objects like your smartwatch, like your smart locks, smart and plug for a large range of service. So here a graph, essentially right now IoT was being used in healthcare, agriculture, warehouse, industry, environmental, and shipment and transportation. Right? You might see a lot of security cameras, so-called IP cameras, right? And healthcare, many of you carry, smartwatch, and they also, have, can capture heartbeat and many other, and health metrics. And for example, another example on warehouse, you might see the movies and newspaper talking about how Amazon using IoT devices automatically, robotics, and doing all those, moving the boxes instead of relying on workers. Right? So it's just you can see the trend, and maybe in 20 years, 30 years, we'll see, rapid, rise of IoT things. It's all connected. Then what is a smart home? So essentially just a home with a lot of smart gadgets, right? And smart plugs and voice assistant, Alexa. You can see here, I have Amazon Echo in my office. So I have Google Home and Alexa because I'm a researcher. And so it seems like I'm have a conversation. So I have to unplug it. So very interesting. See here, and Alexa was, saying I'm having a conversation with the devices. You can see here, and this is everywhere. This is like, you can see these smart offices, right? And like smart doors, you can remotely control your door now. And smart toaster. And so everything we have, a lot of, you probably have more smart devices in your home. And I remember many years ago during Christmas, at night, I have to plug the plug, and in the morning, I have to take the plug off to save, the energies. Now it's just a swipe, because now I'm using smart plugs. You can see here, smart home also have a lot of IoT devices, and there are a lot of amazing functions. So another question is, why do we need to protect IoT in smart homes? Why do we need to secure them? So here's an example. And in 2016, you might have heard about it called a Mirai botnet. So botnet is essentially just a network of compromised devices controlled by hackers. So this botnet is the hack control has millions of embedded in IoT devices. Okay? And they are very powerful. You can see this images, all the red dots indicate and 1 or 2 IoT devices in that location are being compromised, being part of this botnet. And they are really powerful, and they can collect and launch a DDoS attack. The DDoS stands for distributed denial of service attack in 600 gig per second in volume. This is just very, very powerful flood of traffic. It can take down any website. Like say, just think about like if you can control a botnet, send 600 gig per second to any major website, you can effectively take them down. They will be offline because just the load is just too big for them to handle. And also this type of compromise is really fast. So that, another factor is in the first 20 hours, this botnet can compromise 65,000 other devices. So basically the speed of infection is just really fast. And one of the reasons you might ask, why IoT devices be compromised, because one of the reasons because they have weak password. And when people buy IoT device, they never update the password. They use manufacturer default password, like the username is admin, the password is password. So they can see how easily for the hackers to compromise them. So why is it difficult, to protect IT security? One of the reasons is many home users, they don't have, computer science background, they don't have deep technical knowledge and expertise. They just, buy devices from Best Buy and plug it, use it. Oh, it works just fine. They're really, and not, in that technical detail of how to protect it. Another challenge is because we have so many connected devices. Like we only have one cell phone, probably 1 or 2 cell phones, and but if you just look around your house, you might have 10s, 20s, very different IoT devices, right? You have plugs, bulbs, as smart assistant, and the smart refrigerator, right? And so just they are very different and very difficult to manage and secure, because and you are dealing with a very different devices. Another problem is we as the user, human being, and we use weak passwords, 1 2 3 4 5 6, and 1 2 3 key WR. You probably use them because it's just easy to remember, but that's the problem. And some just like no password, and or just use default password from the manufacturer, which is basically you're waiting for disaster to happen. And if because manufacturer password, everyone know it, it's public knowledge. And other things, many users, including ourselves, has a very low cybersecurity mindset, which is, that never happened to me, but you never know. Another reason for, the IoT security in smart home is challenging because, and the profit and market share manufacturer, they just push for IoT devices, which is make to work first and secure the second. Functionality, as long as it works, that's fine, which is not correct, right? Because, and if you have large number of deployed vulnerable devices, and essentially they will be compromised by hackers and controlled by hackers. Right? And finally, a lot of hackers, and they essentially were trying to explore and very weak, insecure home networks and to launch and control and command botnets to control those vulnerable devices. Right? So basically, we have a lot of challenges in IoT in smart homes. So one solution, and my research team, I have a couple of students who work in this area. Basically, we build IoT traffic measurement framework. So essentially, and we collect traffic data in the smart homes, and we analyze it. We collect the data. We figure out a fingerprint. We do the profiling, and we analyze, why. Just for example, why my Amazon Echo was communicating a server in Europe, which doesn't make sense, right? You have to do the deep investigation. It's like, why do I have my credit card was using Europe e-commerce website, right? Is that anomaly? And for that example of Amazon Echo was communicating with Europe computer is because it's Spotify and because it's Spotify servers in Europe. So it's legitimate. But this is one example of legitimate, but many other cases, what if and the IoT device was compromised, controlled by hackers in Europe? So that is the example of IoT security and incident, because my IoT device was compromised, even though it's functioning, right? Just like computers, right? And many of you know, oh, my computer have virus. Your computer works just fine, but under the hood, your computer is controlled, by hackers, right? And so that needs to be removed, and because it is, a security, a risk, they might listen to your network traffic, they might, listen to your keystroke, capture your password, and you username with it when you are visiting banking website, right? So it's kind of like really, really important to identify the threats, identify ongoing compromisations and exploration. Once your IoT device is being used, they might use something else, right? They might launch another attack and also try to compromise more devices, right? So the application include intrusion detection, monitoring, and classifications, which is normal, which is abnormal, right? So I'm not going to go into the details because this takes a lot of knowledge and background to learn. So if you're interested, at least a couple of papers we have published in the recent, and I can send an email if you interested into this type of topic. And I want to wrap up with a couple of questions, like so why we do needed to learn computer science, right? And why do we need to have computational thinking? I'm not just saying you needed to pursue computer science as a major, but computer science actually touch all the STEM field. And I know one word anchor basically was promoting STEM education, and computer science actually involved science, technology, engineering, and math field. And also computational thinking is part of the computer science education, essentially is a process of how to solve problems. And essentially, we all know all the STEM field, essentially we need to solve problems, right? And the key principle of computational thinking include decomposition, pattern recognition, abstraction, algorithm. Decomposition is essentially just like divide and conquer. How are we going to break down the huge sophisticated problems in a smaller manageable sections? For example, how are we going to build Curiosity rover in NASA Mars operation? Now, this is a very difficult problem, but how to conquer that? Essentially, we just one small piece at a time, right? We just divide the challenge problem into smaller pieces, and then we conquer one at a time. I have multiple teams to tackle just small problem, make the problem more manageable. Right? And another principle of computational thinking is pattern recognition. To recognize the patterns. And for example, you might hear like, an image classifier, have the computer recognize, is this a dog? Is this a cat? Images, right? Essentially just, it's patterns. Right? Abstractions is also very important in the problem solving, skills. And essentially just how to generate the problem and focus on the big picture and don't focus on too many details, right? At the very beginning, at the very top, you need to, focus on the big picture. For example, I'm building the subway transit for New York City. right? Let's say if you ask it to draw the map, you probably don't, want to, focus on too much detail on the, the building, tourist locations, and restaurant, etc. They're not important. The most important is how to lay out the, on the major, the trans, all the major lines, and everything else is details. You probably don't want to, focus too much details. You focus on the big picture. The last aspect of computer thinking is algorithm. What is the algorithm? Essentially step-by-step instruction solve problems. You just like build a Lego pieces. For example, build the Lego Millennium, Falcon set, right? They have very, very step-by-step instructions. And what is, the computer science essentially also many aspects of how we're going to tackle problems, with this computational type of idea and solving one step at a time. And you have what instructions to do that, right? Just like many times we human beings are very natural, right? Just like, hey, and I want to, I'm thirsty and I want to I want to drink a cup of coffee, right? So it's very natural. And I just grab the coffee cup and I drink it. Now think about you train a robotic to do it. That's not a very easy anymore, right? Because you have to tell the robotic, how to reach the coffee cup and how to drink it, right? So you basically have step-by-step instructions to coach the robotic to do it, right? Essentially is algorithm. Yeah. I'm going to wrap up with my, and the very short talk, with the article I read yesterday. So this is just published July 12, 2022, and it was probably yesterday on Education Week. It's basically, and the 500 major American companies, including Microsoft, Amazon, Google, and Facebook, they basically was advocating the government, state and the federal government to expand access to computer science. Right. The reason is computer science is really important, and it might in the future, I don't know, the 5-10 years, they might have just, and required a curriculum for K-12 education, just because, and the problem solving skills, computational thinking skill, and it's just very, very variable, skill set we needed to have, and not just for college now, and even for elementary, middle school, and high school, needed to have that type of, training and exposure to computer science. And I'm going to stop here, and I'm going to be very happy to answer any questions you guys might have, related to computer science in a college and etc. So I have first question from Alice. As high school students, how could I start? So I mean, as a high school, how could start to learn computer science? So if that's the case, I think you could, once you could do it, you can just say, if you want to, take AP in computer science classes, that is one possibilities. And let's another possibility, just pick a programming language like a Python, Java, and just learn how to coding. And because a lot of times you need to write software to solve problems. So coding is also a very important aspect of computer science. And you can learn, two major languages I would recommend for beginners, Java or Python. And in ASU, our freshmen learn either Python and Java. So that's also very two major languages. Unmute, just, and talk, directly, that's also fine. And CS classes seems far from research. If you want to join research, I will, I would first of all, and okay, how do I reach a professor? I would suggest you to, have a problem, a couple, it's literally, and I would say this case by case. Let's say if you have an idea, let's say you have an idea you want to solve, like say climate change, right? So you have a wonderful idea and you want to, help from a college professor. And that's one idea. You just approach them, and professor, I have this idea, can you help me? It's a more from collaboration point of view, right? Or you just want to learn computer science, you don't have, you just have passion, right? So I would suggest you just kind of and start to learn language on your own first. So you kind of have some knowledge. So when you have a conversation, you're prepared, right? You just don't want to get in like knock the professor's door. You have no idea what is computer science, what is coding, and you can't start a conversation, right? And you have to explain to convince the professor and why, and you are interested, why it's so important the professor need to invite you to the lab, right? Because every professor has limited lab spaces, right? And they can't just accept all the high school students. So you have to be stand out. You have to convincing, and your case is much stronger, the other students. So I receive, and probably like 20 applications from high school every year. I can't admit local students. So I can't admit like all of them, and because I have very small one lab spaces, right? So I was just getting prepared, and before you reach the professor, prepare the conversations, right, and make a convincing, compelling cases, right? And I would suggest the local, and so you can have a face-to-face and conversation. I know the COVID makes things complicated, but as things and getting better, I would just think, and if you have have a local university, and just knock the door, and typically professor would be very happy. In general, people are very happy to see, the future computer science research scientists. So, and they will definitely give you the opportunity if you present a compelling cases. Okay. How to prepare to meet a professor. And first of all, you need to identify your passion. You have to see, this is what you like to do, right? And why you need to join this lab, right? What could you and contribute, right? Why is a good match, right? Just like think about it. And like say, if you're from Los Angeles, right? Let's say UCLA, they have many professors, right? You just need to understand which professional approach you have, and is match your interest, right? And also have some preparation like coding. So because when you join a project, you need to solve problems. So when you solve problems, typically in most cases you need to write code, right? If you can say, hey, I already learned code, so that means you already and one step ahead of others. Otherwise, hey, we got a problem for you, solve, you have to run code, and it take multiple semester to learn coding well, right? So you just don't want to, I have no idea, no preparation, and I want to join your lab. The first assignment to write a code, it take you 1 year to learn coding, right? So it's kind of like, and not going to work out really well. Okay. I can understand the paper from, okay, so that's fine, that's fine. You don't have to understand the papers, okay? But you need to understand what problem they're solving, right? Let's just say here, I just talk about IoT, and you don't have to understand my paper, but you understand, how IoT works, right? So that is basic knowledge. You don't have to understand the mathematical system. That's why you're learning. But you need to understand, like say computer graphics, right? Gaming, AI. You need on a very basic understanding on the topic. That is good enough for me, right? You don't have to, but once you be, let's say, be part of the lab, then you can start reading the paper. Even for graduate students, at the very beginning, a few of them can understand, because it takes 2 or 3 years training to fully understand and be part of the team to write the papers, right? And how could I understand? So what degree should I understand? So what degree should be understand to talk with professor? I don't quite understand the question about what degree should be understand to talk. How long does it take to get some process degree to papers? I don't just kind of have a very basic idea what they're doing. You don't have to understand how they did it. Just like say, hey, just like for example, I presented probably 10 minutes or 15 minutes. I'm trying to protect ID security. That's good enough. Basically, and there's an IoT weakness in the smart homes, and we are doing work. So you don't need to understand what exactly we're doing, because that's a part of, that's kind of like once you're on board, then you have a learning curve, right? You don't have to be prepared, learn everything before. Then you don't need a journal because you already know everything, right? So progress. Yeah. How long takes some progress? So if you're high school students, you want to be part of the research team or in a professor team, I would suggest you start from freshman, like say summer freshman. The earlier the better, because let's say you're rising senior, and at that time it's just too late for you to join, because it takes multiple years to build something really important and be like publishable, meaningful, right? Because first of all, you have 3 months learning curve, right? And then you need like 1 or 2 semesters to get meaningful work done. That is 2 years, right? So I would suggest as early as possible, like, and maybe at the end of 8th grade, that would suggest, I mean, the earlier the better, because, and to get, really awesome work done, you need a multiple work. For example, a PhD, typically PhD student take 5 years, right? You can see, that's because we're not just talking about a very small work, and because you have to solve, very complicated problems, it takes years of effort. So if you want to be part of the team to do something, really fantastic, prepare early. Okay. So it's late. And I would just, I'm not trying to encourage you if you're a rising senior, you can still be part of it. Let's say you can get, it really depends on, what do you want out of it. You can get a, exposure, and you can be part of the team. But if you want to say, hey, you know what, I really don't want some like get a publication, on my college applications. At that case, if you're right now rising senior, I would say just too late, because it takes 6 months to get accepted. There's a review cycle. When you want to publish, but you have to submit. Typically, submit it takes 6 months, and sometimes take years to get it reviewed and publish it. So so let's say here is a timeline. You have an idea, you get work done, you write, you submit, and you get reviewed, then you get published. You can see here there's a long timeline. By the time you have an idea to publish, it typically take 2 years. Okay, so that's typically maybe 1 or 2 years, right? Many conference takes 6 months just for review to accept. Publish is another 3 months, so it's really a long cycle. So I would say the earlier the better if you want to have a publication on your resume. Okay? But if you want to learn something, it's never too late, right? If you say, hey, I just want to have fun and learn something, that never too late. You can join any time. But if you want a publication, my advice is the earlier the better. For LSAT, if they're too hard for middle school to understand. Okay, so if you're 8th grade, congratulations. Right now, if you're in the seminar, if you're listening right now, I think you probably one of the people who prepare. Congratulations, and don't worry about and you couldn't understand. That's okay, because that's why professor put in the team, and you definitely have that opportunity to learn, understand later. So you just need to have. But I would say you need to understand. You need to know how to coding, because coding is basic. You don't have to understand any different discipline. You can just prepare for every professor conversations. But you need to coding. You need to write code. If you write the code and understand a certain area, I don't think that is hard. You just need to spend some time and learn. Like say, if you join the lab, you learn from undergraduate to graduate student. You have your own learning curve. Every lab has a learning curve. That's fine. And but if you're 8th grade, 9th grade, you have a lot of time, and you're not super busy. Not like just seniors. You have a lot of application, assets to write. And if you have a lot of time at that time, I would say you're gonna have a pretty decent chance. Very nice work, working with professor for 2 or 3 years. You definitely will have, some productive, result. Okay, so it's harder to know, what do I want to know? That's fine. Just explore, if let's say you spend a couple months in the lab, you feel like, I really don't like this topic. That's fine. You just, and just be frank, tell the professor, this is not my thing, and then just try another topic that interests you. But your preparation of your coding, that effort is not wasted, right? Because you already understand coding. That kind of skill can help you to quickly transition to topic you love. So, and even for the learning curve from the lab can also be beneficial, right? Because you know how to read and how to approach problems, and also you learn from other students, undergraduate and graduate students in the lab, how they solve problems. How they tackle challenge, so there's a lot of, practical knowledge, from just be part of the team and in the lab. Okay, so if you don't have questions right now, and that's fine, feel free to send me email, and I'll be happy to answer. And you can find my, I can just type my email address on my ASU, and you can also find my information on the search, just search my name at ASU, you'll find my homepage. This is my email address, and feel free to send me questions. I'm happy to answer. Okay. And bye and good luck, everyone.